Let's look at some techniques for solving equations. Some of the terms we'll be using in this lecture include constants, which are fixed numerical values like pi, variables, which are just symbols that can take different values like x or y, terms, which are combinations of these two things through multiplication and division, like 3x or pi y. There's also something known as a coefficient, which is just a number in front of an expression, like 7x or 7 times x plus y. Then there's an inequality, and we haven't really touched on expressions, we'll do that soon. An inequality is a combination of two expressions in an inequality, and an equation is the same, but the two expressions are equal. Now, what is an expression? An expression is just a combination of terms. So we can say 3x plus 5. This is an expression. So an equality could look like 3x plus 5 equals 4x. And this could be 3x plus 5 is greater than 4x. So they're not equal, but one is greater than the other. So expression is like a base term which you'll end up using a lot. Right? You use that when you're talking about equations or inequalities. And this itself is built up of a term, and a term is built of variables and constants. So they all relate to each other, and they're all important to know for this. Now, what are we going to be learning? Well, we're going to begin with isolation, which is just a way to solve single variable equations, and it's like the basis for solving any type of equation. Then we're going to go on to substitution and elimination, which sort of go hand in hand. They're basically extensions of isolation. And then larger systems, which are extensions of even this. And then review and practice, we'll get to that at the end. So isolation. Isolation is the most basic method of solving an equation. So let's say you have 5x equals 10. You want to isolate x. So what you do is use the properties of equality. So the division property of equality would say you can divide both sides by 5, and this would result in x equals 2. So you've isolated x, the variable, on one side, and all the constants and the other terms on the other side. So that's basically how isolation works. And here you can look at some examples. So here we had 4x plus 5 equals 33. Then we subtracted 5 from both sides and divided both sides by 4. So the steps are all listed here if you want to follow along. And basically we just isolated x. Right? Same exact thing here. Here we subtracted 4x from both sides and subtracted 8 from both sides. And there are a lot of different ways you can do it. That's just one of the ways that I did over here. And then I multiplied both sides by -1 to remove the negative x and make it just an x. And that gives x equals 15. Same thing with inequalities. Inequalities also work with isolation. So here again we added x to both sides, subtracted 5 to both sides, and then we divided by 3. So nothing too complicated there. Now over here there is an important, not really a trick, but just an important thing to keep note of. Whenever you multiply or divide by a negative, when you ever multiply or divide an inequality by something negative, you always have to flip the inequality sign. So I've written that over here. This is very important. Okay, this is very important. It's an easy way to mess up, so just make sure you get that done. And now let's move on to substitution. Substitution is just an extension of isolation, and it can handle more than one variable. So to take a look at that, let's say we have x plus 5 equals y. Okay, now already we see this is one variable, this is another. So there are two variables. And then we have 3x plus y is equal to 20. Okay, let's say we've got this. How would we do this, right? Now we've got two variables and we can't really isolate it, right? Well, we can. Instead of, we can't isolate both variables at the same time, but we can isolate one of the variables and then substitute it. So that basically two steps to this. You isolate one variable, so that's the first step, and then you can substitute it. So let's look at that. To isolate it, well, for here we've already isolated y in terms of everything else. We've got x plus 5 equals y, right? So now we can plug this value of y in, and when we plug it in here, we get 3x plus, instead of y, we can just write x plus 5. So we're substituting, we've isolated y, that's the first step, and now we're substituting its new value in over here. And if this equals 20, that means 4x, just distributing, plus 5 equals 20, which means 4x equals 15, which means x equals 15 over 4. If x equals 15 over 4, now remember we aren't done, we've only solved for x. So now we need to find y as well. So let's go back up here. We can do 15, over 4, so that's x, plus 5 equals y, and this gives us, I believe, 35 over 4 equals y. So our final answer, and I know it's become a bit messy, I'll just write it over here and box it here, is x equals 15 over 4 and y equals 35 over 4. And now if you want to verify that, you can just plug it into either of these equations and then check that it works. I'm going to go over one of them and leave the other one for you to look over on your own. So here we basically solve for x in the in the second equation. Then we substituted a new value inside the first equation. Once we solved, we got y equals 1, and then we put y equals 1 back into the x equals 2y minus 1 equation, which gave us x equals 1. And now you can write x equals 1, y equals 1, but another shorthand for writing that is just 1 comma 1 or x comma y equals 1 comma 1. And this is a very similar process, and so I'll let you figure that one out on your own. Now let's move on to elimination. Elimination is very similar to substitution, and it's basically an extension of isolation as well, except it eliminates or removes a variable, and sometimes it's faster and shorter, but sometimes you have to use substitution instead. It depends on the specific case, but let's look at elimination. So let's say we have 3x plus 5y, and let's say this is equal to let's say this is equal to 8. Now let's say we've got 2x plus 10y is equal to 22. Okay, so it's a bit weak. Do we really want to substitute? We'll get a lot of messy fractions, right? Like if you try to substitute x over here, if you try to isolate x, you'll get x is equal to 8 minus 5y over 3, and then that's just going to be a bit messy. So is there something else we can do? Well, what do you think elimination means? Elimination means you're going to eliminate something. When you eliminate something, what you're basically going to do is try to cancel out one of the variables. So let's treat this as equation 1 and this as equation 2. So what happens if you multiply this entire thing by 2? We notice that there's 5y and 10y, right? So we want to make this 10y, and then we'll subtract one equation from the other, and that way we'll be able to just cancel out the y. Okay, so let's do that. This will give us 6x, so this is 2 times 1, so just multiplying everything by 2, and this will give us this equation right here. And now we can simplify that by subtracting either one of them. So let's do 2 minus 1. Okay, so now you might see why these are useful. It makes it a bit easier to just see what's going on. 2 minus 1 gives negative 4x is equal to 6, which means x is equal to negative 3 over 2. And if x is equal to that, now we can plug that in over here. And I don't really want to do it, but well, let's do it. So if you plug that in over here, let's do it in equation 2. That would give us 2 times negative 3 over 2 plus 10y equals 22. That becomes negative 3, so 10y equals 25 and y equals 5 halves. And again, remember, if you want, you can just write this as negative 3 halves, 5 halves. So I will do that here. Now there's an example here where it's like a word problem. So John is 7 times as old as his son. 3 years from now, he'll be 5 times as old as his son. How old was John 5 years ago? So we'll just set up an equation. So this is John's age, J, and S is his son's age. So right now he's 7 times as old. So J equals 7S. But in 3 years, which is J plus 3, he'll be 5 times as old as his son. So J plus 3 is his age in 5 years. And 5 times S plus 3 is 5 times his son's age in 3 years. So now we go, and what we're able to do is just do 2 minus 1 immediately. Right, that really simplifies things because we've got a j and j here, and we can just subtract that out and cancel it out. And so we're able to solve the equation to get s equals 6. And if s equals 6, j equals 42, right? You can use the first one over there. And since John is 42 now, what is the question asking? How old was John 5 years ago, right? So read the question carefully. He's 42 now, so 5 years ago he would have been 37. Now, larger systems are a bit more interesting. You can solve them with previous methods, but it just takes a lot longer, and you can probably imagine that, right? Like let's say you have x plus y plus z equals 10, and then you have like more and more equations like that. The thing is that it does get a bit irritating, right? Like you don't want to keep on substituting or keep on eliminating. So sometimes there are actually tricks. Sometimes they won't ask you to solve the system directly, they'll ask you for the sum of all the terms. So there are a lot of tricks like that, and you'll be able to go over that in the practice that I'll attach later, and I'll talk about that later. But there's some more important terminology relating to this. So when you have a system of equations, if there's at least one solution, the system is consistent. But if there's not at least one solution, then it's called inconsistent. And if one, so let's say you have x plus y equals z, right? This is just an equation. But now what if your second equation is 2x plus 2y equals 2z? Well, when any equation in the system is a linear combination of the others, basically when it gives no new information, then it's called dependent or redundant. This system is known as a dependent or redundant system. So over here, does this really give us any new information? No, it's just twice the first equation, right? So we could have found that out on our own. It didn't give us any new information that we can use. And if all equations are independent of each other, like none of them are built on the other ones, then it's called an independent system. And we can actually extend this more. So let's say there's x plus 2y equals 2z, let's just say that. Then would this be independent or dependent if we get this one? Okay, so this would also be a dependent or redundant system, since this thing over here, this thing is just equal to the sum of these two. See, 2x plus 3y equals 3z. Now for review and practice, isolation is the most basic method for solving equations, but again it only works for single variable equations, and you can extend that with substitution and elimination, and you can use that to solve larger systems. Then there's this important vocabulary which we just defined in the previous slide, which you can go back and check out. This and this. So these are important classifications. Remember, now these are some tips for the upcoming problems. Factoring can be useful in questions, as you will see in the practice problem set. And also remember to focus on what the question is asking. So you saw some of that in this question when it said how old was John 5 years ago. So you should always read it carefully, especially in the larger system problems. Often you won't be asked to just solve the system. You'll be asked for x plus y plus z or something like that. So you should always be careful with what you're reading. And that's all for this. For more information, for the practice problems and everything, go to my website and you can find it all over there. Thank you so much for watching.